7 over 10 times 1 over 5. And it asks us to multiply. Shh. So we have to multiply. When we multiply fractions, you guys really like cross multiplying, but you only cross multiply across an equal sign. Is there an equal sign in this question at all? No. They also won't often even say multiply. They'll just say simplify. And then you're like, well, what do I do? Multiply, because there's a multiplication symbol. Okay? Now, when you multiply fractions not across an equal sign, you multiply numerator times numerator, denominator times denominator, reduce. Okay? If it was just one of these big old fractions. So I'm going to go 7 times 1 is 7, over 10 times 5 is 50. I can't reduce it. I am done. Okay? So you have the notes in front of you. You're just filling them in. That was A. B is 9 over 10 times 20 over 21. So, and you're going to know this with rationals. What you can do is you can reduce anything if there's a match in the numerator anywhere with the match in the denominator anywhere. So, for example, 9 and 10 I can't take anything out of, correct? 20 and 21 I can't take anything out of, correct? But 20 and 10, I can take what out of both of them? A 10. And because 20 is in the numerator over here and 10 is in the denominator over here, completely fine. You have to be in the numerator somewhere, denominator somewhere. Okay? So 20 divided by 10 is 2. So now I'm left with a 2 here. 10 divided by 10 is 1. 9 and 21, is there anything I can take out? A 3. 9 divided by 3 is 3. 21 divided by 3 is 7. And then I've reduced them as much as I can, and then I just cross the top, multiply across the bottom. So 3 times 2 is 6 over 10, or 1 times 1 times 1 times 7. 7. So it is a lot easier if we reduce as we go along than if we just multiply across the bottom and then have to reduce it. Okay? Now you're like, well, my calculator will do that for me. Yes, it would if I was actually asking you to do fractions. But I'm not asking you to do basic fractions. I'm asking you to simplify rationals. So we're going to look at the first example here. Consider the multiplication of x plus 1 over x plus 3. I'm going to go times like this. I always do closed dots for multiplication in the rational unit because x's and multiplication symbols look a heck of a lot alike. So I just do the dot because the dot is another multiplication symbol. 2x plus 6 over x squared plus x. So let's think of this as 2 simplification questions from yesterday. That's all it is. Okay? Here's one simplification question. Here's the other one. Okay? So what do we do when we simplify? We look at all the numerators separately, all the denominators separately, see if we can take out GCFs or difference of squares, right? We're just doing it to 4 now instead of 2 like we did yesterday. So x plus 1, can I make it any more simple? No. I'm going to say this expression equals my next expression, okay? So I'm going to have x plus 1 in the top in brackets because why? They're attached by a plus sign. So the x is sewn to the 1. They're together bracketed, right? And the x plus 3 in the bottom, can't take anything out, but it's attached with a plus sign. They're sewn together, so I put them in brackets. The only way they're going away is if they have matching replicas in the numerator and denominator that can cancel them off, right? Okay, so that would be like yesterday. Now we'll pretend that we're still going from yesterday, but it's a new question. So in the numerator, I have 2x plus 6. What could I do? Take out a 2. And then I'm left with, now if I remember, if I have 2 terms and I take out a GCF, I'm still going to be left with 2 terms. Yeah, a 1 in the end if it does that. You're right with what you were saying indirectly. So we're going to have take out a 2 and we're left with x plus 3. And then the 2 goes in its own brackets because it's out front. What about the bottom, the denominator on the right? And now I'm left with x plus 1. And this x goes in brackets. So what we did in the past is anything that was in the denominator we stated NPVs for, right? We just happen to now have 2 denominators. So we have to state 3 NPVs. This one, and that one. Do I care about either numerator? Can the numerators equal 0? Can numerators equal 0? Yes, because if you do 0 divided by a number, it's just 0. But denominators can't equal 0 because you can't go a number divided by 0. You would get undefined. Okay, so we're going to get x plus 3 cannot equal 0. We're going to get x cannot equal 0, x plus 1. I would show your work whenever it's a written response. I would also show your work whenever it's anything because you make mistakes when people don't show work. And it's like 30% of your mark at the end of the year. I would make sure I show my work, yeah. You could, but if you screw up, you're not going to get any mark. Or you might screw up also a lot more easily. So x cannot equal negative 3, 0, and negative 1. Like these ones were easy ones. But like if the x is negative, for example, people get those ones wrong all the time. So we have our 3 non-permissible values. If we want, we can write them together, so we have them together. Negative 3, negative 1, and 0. Okay. So what do? What can I do now? Anything? Yes, because I stated non-permissible values. Remember, if you're like, I never know when to state non-permissible values, the moment you go to cancel, you better have stated non-permissible values. So that's like a hint. If you go to cancel, be like, did I state non-permissible values? If I haven't, I needed to. Okay? So I have an x plus 1 in the numerator on the left and an x plus 1 in the denominator on the right. Can I cancel them? Yes, as long as one's in the numerator and one's in the denominator. What I get people doing is they'll have an x plus 1 in the numerator on the left and an x plus 1 on the numerator on the right, and they try and cancel them. Can you do that? No, you need to have a matching replicate in the top or the bottom. So x plus 1's cancel, x plus 3's cancel. This 2 and x is left over. When you're done, all you do is multiply the tops together over the bottoms together. So it's just going to be more multiplying together, just like we did with simplifying, right? 1 times 2 times 1, which is 2. Over 1 times x times 1, which is x, followed behind with x cannot equal negative 3, negative 1, and 0. So basically the same as yesterday, just more, right? It's like 2 simplifications put together. And flip over. So it says simplify the following, state the non-permissible values as restrictions of the values of x. So we have 4x minus 6 over 14x minus 7 times 2x minus 1 over x minus 4 squared. Okay, so what do? Simplify as much as I can. So example 2, the top, the numerator. What could I do? Take out a... Oh, it's a 16. Good call. It's a 16. So what could I take out? A 4. And I'm left with x minus... The denominator, what could I take out? 7. And then you're left with a 2x minus 1. Remember, if we take a GCF out of 2 terms, we need to be left with 2 terms. The top right, the numerator on the right. Can I take anything out? No, I'm left with 2x minus 1. The denominator, you can't take anything out, but I would suggest you always do this. So when you have one with a squared, that just means you have how many of them? 2. So what I always do is just write them out twice so I don't accidentally cross them off wrong. So I'm going to go x minus 4 times x minus 4 like this. So if I have 2 of them, do I have to state x can't equal 4 twice? No. As long as I state the non-permissible values that would make the denominator be 0 once, then I'm saying, hey, don't do this, and then I don't have any problems, right? I don't need to state it twice. Like, it's super important or anything. It's the same thing. The 4 and the 7 out here go in brackets. So we have MPVs. Does this 7 get me a non-permissible value? Can 7 ever be 0 anyhow? No. Really bad English right there. So 7 can never be 0. right? Our only issue is that we're doing rationals and they have variables. If there was no variable in the denominator, we wouldn't have issues, okay? Then we have 2x minus 1 cannot equal 0. And we have x minus 4 cannot equal 0. And we only have to state it once, because once we find out what x can't be, we're golden. We've gotten rid of all the problems. Add 1. 2x cannot equal 1. Divide by 2. X cannot equal a half. Add 4. X cannot equal 4. And I can put them together if I want. X cannot equal half and 4. Yeah. It's a 1-for-1 deal. 1-for-1. One numerator for one denominator. So, isn't that great that I knew what you were going to ask? Because everyone asked the same thing. See, it was a good question. So x minus 4, there's how many in the numerator? Are you okay, Caleb? Okay. There's 1 in the numerator, and you can only cross off one of them in the denominator. It's a 1-for-1 deal. Then what? Yes. Wait, I have a 4 up in the top and a minus 4 in the denominator attached to an x, so I'm going to cross them off. Not a sir, but thank you. You still cannot. So x minus 4 does not have a matching to the numerator, so it cannot cross off. Okay? So we're as good as we get. So we're going to have a 4 in the denominator, and then we're going to have a 7x minus 4. Now, if they have it, so rarely do they do this, but if, say, they asked you for an answer and they said it had to be in the form 4 over ax minus b, what's a and b? Say they did this. Please pay attention so I don't lose you on tests if this happens. So this is the form we got, and this is the most simplest form. That's actually a better form, right? Because the 7 is pulled out, it's simplified. When you put it back in, you're actually expanding, which is not making it more simplified. But if they say, I want you to simplify it into this form, and you give me the answer 7 and a negative 4, or 7 and 4, sorry, you're not right. Does this have a bracket? No. So if this doesn't have a bracket, neither can this. So what would I have to do? Right, yeah. So you have to go 7x minus 28. And then you'd go 7 plus 28. Now, if we did that, so in the bottom we'd have 7x minus 28 and a 4 on top. Why would we go 7 plus 28 and not 7 minus 28? If I asked you for the sum of the two, if I asked you for a plus b. A is actually what's in front of the x, which is 7. And b is what's behind the negative sign. So it's 28. The only way this would be actually negative 28 is if in between ax and b I had a plus sign. If I had a plus sign, then it would have to be plus minus 28, right? So keep that in mind. If this is a minus sign here, I just take the 28. Okay? They could ask you for this. If it's a plus sign in between these, so say I had 4 over ax minus b, and I had 4 over 7x minus 28. Then I just take what's there, right? So what's in front of the x is a, what's behind the negative sign is b. We agree? But if I had put a plus sign in here, is this a plus sign? No. So I would have to go plus, and the negative would actually join the 28. It's true. Because this would be plus whatever the heck b is. So I would need a plus sign here, and b would have to be negative 28. Because it would be 7x plus negative 28. Yeah. Plus minus 28. Yeah. And honestly, they often don't ask it in this form. This is not the form that's really that bad. They don't usually do it that way. They usually do it this way, and people mess it up. So ax minus b, 4 over 7x minus 28. This is the one they usually mess up because they'll say 7 and negative 28, and they're like, it doesn't fit in the numeric response box, so I'll just leave a negative outside the box. No. So it's going to be 7 and 28 because the minus sign is not b. The minus sign is what's in front of b. So it's more so this that's the problem. get ones like these, where b is actually what's beside the minus sign. Okay? That's a good answer. Here, x cannot equal 1/2 and 4. You guys try b. I'm going to go through it after. You're just going to try it first. Oh. So here, we're going to take, pay attention please, we're going to take out a 2x squared, and then we're going to be left with x minus 2. And then take out a 3x, and you're left with x minus 3. You have 1x left and then a 3, multiplied by x squared. And then this is the difference of squares, x plus 2x minus 2. And then I state my non-permissible values. This 2 can go in its own brackets, the x squared, the 3, and the x. 3 can't give me a non-permissible value. X can't equal 0 from the x. X minus 3 can't equal 0. X plus 2 can't equal 0. X minus 2 can't equal 0. 0. This one's done. This one's going to be x can't equal 3. This one's going to be x can't equal negative 2. It's going to be x can't equal 2. So we have x can't equal 0 plus or minus 2 and 3. Okay, then we have to do simplifying. The x minus 2's cancel. X plus 2 is going nowhere. It doesn't have a matching replica in the numerator. X minus 3 is going nowhere. It doesn't have a matching replica in the numerator. So if you're like, I'm not sure if I can cancel anything else, then don't. Just put them together and then you can see. So I'm going to get 2. And then I have x squared times x squared, which is x to the what? 4, because it's x times x times x times x, so I have 4 x's. And they can go in separate brackets. Over 3 times x minus 3 times x plus 2. Then sometimes when you put them together, then you spot, oh, wait a second, I have 4 x's up here and 1 down here, right? So I can cross off one of them. So it's okay if you don't cancel them all off perfectly right away. You can do an extra step. It's not the end of the world. So this x and this one crosses off and I'm left with 3 of them. So my answer is 2x cubed over 3 x minus 3 x plus 2. X cannot equal 0 plus or minus 2 and 3. And that's as good as it gets because I have nothing else that can. Yeah. Then we're going to look at 2a. I just wanted to look at it because it's a really easy question and therefore you guys find it really difficult. It's just how it works in rationals. Like the easy monomial ones, you guys are like, I have no idea. And I give you like this complex difference of squares, take a proper negative, all this stuff, you can do it. Then I give you a monomial and you're like, meh, I don't know what to do. So this one simplify and it says 8x squared over 25 times 50 over 2x cubed. So remember, all of these can be in their own brackets because there's no plus or minus signs, right? So I have an 8, I have an x squared, I have a 25, I have a 50, I have a 2, I have an x cubed. The only thing I have in the denominator for a variable is x cubed. And if I have an x squared, an x cubed, an x4, all of them by themselves, what's my non-permissible value? If I have an x cubed by itself or an x4 by itself or an x 100 by itself, not equal to 0. And I say, is there anything I can take out of them in the top and the bottom? I have 2 x's in the top. They can cross off 2 of these, so I'm left with 1. And then I have 25 and 50. I can take a 25 out of both. Here I get a 1. Here I get a 2. 8 and 2, I can take out a 2. So I get a 1. And I get a 4. If you miss any, doesn't matter. In the next step, you can cancel them. It's not the end of the world. So we have 4 times 1 times 1 times 2 times 1. So I have 8 over 1 times 1 times 1 times 1 times x. So it's equal to 8 over x, and x cannot equal 0. For your homework, can you please circle the following? Two, B, and C. Look at C. C says x over 24x to the 5 times, when those brackets are side by side, that's times, negative 14x squared. But remember, we need to multiply fractions, right? So if something's not over, if something's not a fraction, what's it over? 1. So just put a 1 underneath there. And then you multiply it. Okay? So 2b and c, 3b and c, 4b and c, flip over, 6 and 7. So I said 2bc, 3bc, 4bc, 6 and 7. We need to be really good at these because these are very similar to simplifying. And we have to be really good at them because division is just a flip and the exact same question with an extra MPV. So get working.